One security issue that you need to consider is secure communications. And one of the ways that you can provide secure communications between the client and the server is using SSL. So this is one of the simplest and most effective protections that you can implement. All right, an SSL is, of course, Secure Sockets Layer. And it's an HTTP protocol that encrypts the traffic between a user agent and a server. Now, this isn't foolproof. There have been some clever attacks over the years that have exposed some weaknesses in the protocol. But the end result has been to help make them stronger. The real benefit of SSL is it obfuscates your network traffic when transmitting and receiving sensitive data, enough that an attacker has a very short window in which to take advantage of the data. It's also very easy to use, so you should use it to protect all your application's sensitive data. At the very least, your authentication views, as well as any time personal data is sent, such as credit cards and other financial information. Arguably, anything that could be used to facilitate identity theft should be protected, including home addresses and the like. And in a moment, I'm going to talk a little bit more about the full range of benefits of SSL. Now, one of the things about this is that it does require a certificate from a third-party certificate authority. So this is a bit of a downside, mostly because this costs a little bit of money. But the good news is that these days it doesn't cost a huge amount, unless you go for the highest level, ultra-safe and secure extended validation SSL certificate. Those are the ones that turn the address bar green in most modern browsers. Those usually cost a few $100s a year, and probably aren't justified unless you run a large e-commerce site or other financial services kind of a site. For other purposes, you can probably get by with a certificate that costs less than $50 a year. Now, a little bit about terminology, SSL and TLS. SSL, like I said, is Secure Sockets Layer. And that's the term that we used to use to describe the cryptographic protocol used for communicating over the web. SSL provides an asymmetric encryption scheme which both client and server can use to encrypt and then decrypt messages sent in either direction. And Netscape originally created SSL back in the 90s, and it's since been superseded by TLS. TLS is Transport Layer Security, and it's the successor to SSL. And you'll frequently see TLS version numbers alongside SSL equivalents. So TLS 1.0 is SSL 3.1, TLS 1.1 is SSL 3.2, and so forth. So these days, you'll usually see secure connections expressed as TLS versions. I do tend to use these terms interchangeably, but the intent is usually the same in that they both refer to secure communications over HTTP. The important thing about SSL is that it's not just encryption. It's really about three things. The first is site verification. It provides assurance of the identity of the website. So user agent is able to verify that a certificate is associated, a proper certificate is associated with the site that you're actually on. So that's site verification. The other is data integrity. So SSL provides assurance that the content has not been manipulated in transit, because as soon as you do that, it breaks the digital signature of the data that's being transmitted. And then it also provides data confidentiality. And this is assurance that eavesdropping has not occurred within transit, because the data is strongly encrypted. So encryption, as we usually think of it in the context of SSL, is a factor, and particularly in the last two, data integrity and confidentiality. But it's not the be-all and end-all of SSL, and this is the source of a big mistake that a lot of web applications make. So the biggest mistake that you see all the time on the web, it's disheartening how often you see this, is when you display a form, and the form requires the user to input sensitive data, like login credentials or credit cards or whatever. The big mistake is to display the form using HTTP, but posting to HTTPS. And so as an end user, the only way you really know that's going on is that first you notice that you don't have the padlock in the browser that indicates that you're on a secure site that's protected by SSL. In order to see what the form's submit button does is you have to actually look at the view source and look at the attributes of the form element to see whether or not the data is going to be posted using SSL or not. Okay, so this is a big mistake and a huge security vulnerability. The reason is that it leaves the form open to attack before the user even has the opportunity to send any data to the server. So you're loading a form insecurely that's going to be used to transmit secure data. And if an attacker gets access to that form, such as to be able to inject a keylogger into the form, all is lost. And a keylogger is only one way to attack the page. And I'm really sorry to report that one of the banks that I have an account with does exactly this, so that they can get the username using a text box on its home page, which of course is protected by SSL once the user submits the form, but not the form that's originally displayed to the user. Bad, 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 evil. Unfortunately, or fortunately, I don't know, it's a cool bank. You know, about as cool as a bank can be anyway. But I don't use their online services anymore because it's just too easy for an attacker to manipulate it in order to capture my login information. Now, to the bank's credit, all they're gathering on that front page is the username. They're not doing the password, but you do see an awful lot of sites where the password is part of that form as well. So this particular bank, not quite as bad as it can be, but it's not good. All right, so that's SSL. Let's start talking about it in MVC. The nice thing is that MVC makes it easy to use with the require HTTPS attribute. And you can set this on any action method or on a controller. And as usual with these attributes, if you put it on the controller, it applies to every action method within the controller. And the way this works is that non-SSL requests to the controller or the action method are redirected to the SSL version if it's an HTTP GET request, or the request is rejected if it's an HTTP POST request. Okay, so that's the default behavior. If you want to change that behavior, just make it automatically redirect under either of those scenarios. Then you can override the require HTTPS attribute and change that behavior. And so what it does is it forces any unsecured HTTP request to be resent using HTTPS. The one kind of downside of this is that it has a few issues during development. And you'll see those in just a few moments when I show you the demo. But first, a side note. It's important to use HTTPS when authenticating using Google. Google considers someone logging in with HTTP as different from someone logging in with HTTPS, which can cause problems, even if the login credentials are identical. So if you're authenticating against Google, just always use SSL and you'll avoid any problems. Using require HTTPS is quite easy. So here I have a couple of action methods. So one is optional SSL. It has no attribute on it. So if I come at this with SSL using the HTTPS protocol, no problem. If I access it using HTTP, also no problem. And all this does is it displays a message. It says the open secret MVC is cool. Okay, so I make no secret that I think MVC is pretty cool, specifically ASP.NET MVC. So I don't really need to protect that. That's not sensitive information. And then I have an action method that I want to require SSL for. So I use the require HTTPS attribute, and that will cause that action, where if it's a GET, it'll redirect. If it's a POST, by default, it will display an error. Okay, and so here, this secret, this is information that I don't want to be too public, that I think that MVC rocks. Not just that it's cool, but it rocks. So I'm protecting that using SSL. All right, both of these action methods use this secret view. So if you take a look at that, just to show you everything that's going on here, you can see that this is a pretty boring view. All it's doing is displaying that ViewBag message. Okay, so let me go ahead and run the application, run it in Internet Explorer. There's my home page, and I already have developer tools running. So I'll go ahead and click on Optional SSL, and there you can see that I get the page, no problem. And I continue to use HTTP, so this is a typical action method. So in fact, if I start capturing network data, I'll go back and run that page again, and you can see the request headers. So I have the request, and I have the accept, refer, accept language, going down. Okay, everything's fairly typical. And here's the response headers. Pretty much as I expect. Cache control is private. That's the default. And go down here. Okay, everything looks pretty good. All right, I'll go back over here. And now I'll click on Require SSL. So now we get a decidedly different result. Okay, page can't be displayed. So we have some kind of a problem. All right, if we look at the request headers here, look at the request there. There's the GET request. Okay, so that should have triggered a redirect. And there's my accept and on and so forth. Okay, so this is all fairly typical once again, nothing all that special. I'm just requesting a different action method. Nothing in the body, and here are the response headers. Okay, so we have the response. It was in fact found, kind of contrary to what the page says. Private content location. Okay, so what's different is this location parameter here. So what this is doing is, this is the action method, or really ASP.NET, telling the browser that you can't access this the way you want. What you need to do is go to this location right here. And really the only difference, or the main difference, is that it uses the HTTPS protocol here. So under normal circumstances, the browser would get that and re-request the page. But Internet Explorer, being paranoid, gives this page can't be displayed message. And it has some ideas for resolving the problem. Okay, so I can tell you that this address is correct. I can look for the page for the search engine, but it's not going to find anything because it's not running my local machine. And refreshing the page in a few minutes or a few hours or a few days ain't going to make any difference whatsoever. So what happened here? Well, this result is actually expected. By default, Visual Studio 2012, a web project, uses IIS Express during development. And when I hit IIS Express with the HTTPS protocol, IIS Express uses self-certs, and those are built into IIS Express. They're not secure, they're not something that you can use out on the web, they're not trustable, but for the development environment, they work great. Well, or don't look like they work great, but we can make them work great. Okay, so ostensibly, this is really a problem with the certificate, but it's more specifically a problem with the port number. Okay, so if you look up here, notice that we have a port, 17233. If I go down here to the IIS Express icon and right-click on it, look at security, notice that we do in fact have a 17233 port application running. Okay, but what happened here is that the server redirected to HTTPS, that's the good part, but it redirected to localhost without a port number. And that's actually what can't be found. Okay, so this is really just an issue with IIS Express during development, rather than a problem on a production server. On a production server, full version of IIS is going to do the right thing. Again, assuming you have a certificate installed and everything is configured correctly. But this problem is annoying. So does it mean we can't test our SSL pages? Well, fortunately, the answer is yes, mostly. All right, so a little bit of background on IIS Express. The nice thing about it is that, unlike the ASP.NET development server that was used with earlier versions of Visual Studio, IIS Express does support SSL using self-certs. But I'm not yet hooking into it. Again, I can tell that because I only have the single web URL that's running. And there's nothing included for HTTPS. All right, so this problem is easy to fix. I'm going to close the browser, stop execution, and I'll go to Solution Explorer. And I want to open up the Properties window for this project. Not the property pages for the project, but the Properties window. And for that, it's easiest to select the project and press F4. And there's what I need right here. So by default, SSL enabled is set to false. So I'll double-click on that and set it to true. And notice that one of the things it does when I set that to true is it set this SSL URL to HTTPS, localhost, and then a different port number. Because I need a different port number in order to use SSL. And that's the case in IIS Express as well as a full version of IIS. Now, if this is the only project that's running SSL in IIS Express on this machine, then that port number is going to be 44,300 as it is here. But if I were to open up another instance of Visual Studio, load another project where I enable SSL within IIS Express, then that port number is going to be 44,301. If I open up another instance, do the same thing, it'll be 44,302 and so forth. So it's using a progression of port numbers. And notice that these are disabled. I can't change them. I can highlight it, but if I try to type something in there, nothing happens. Okay, so those are set by IIS Express. You can actually set those separately, independently, but that's a whole different thing. Okay, so I've enabled that. I'll save the project for good measure. Come back down here into IIS Express. And notice that now I have two URLs that are being served up by this instance of IIS Express. So we have SSL. All right, so I'll run the application again. Okay, I'll start capturing network traffic and then click on the SSL link there. And we still have the same problem. Okay, so still the website can't be found. Well, geez, now what? Well, let's take a look at the headers here. So I have the original refer, which is localhost 17.233. Okay, and I can see that within the URL. And then here's the response headers. Notice that I have this location. It's setting HTTPS correctly again, but I still don't have a port number. So this page still can't be found. Okay, now again, this is not going to be a problem if you're using the default 443 port for SSL or are using the full version of IIS. But IIS Express doesn't use that default port. Now I got to tell you, this initially drove me nuts. What's the point of SSL support in IIS Express when it works like this? But it turns out this is actually a problem with the require HTTPS attribute and slightly with the action link helper method. Require HTTPS just redirects the browser to the link without port number, but with the HTTPS protocol. So this is what it is designed to do. So it's setting this location header. And typically that's correct. Now, Action Link has an overload that lets you specify the protocol, but one, you have to know that you want to use SSL when you create the link, and two, the overload makes you essentially build the entire link. It doesn't let you get away with just specifying the protocol. You have to specify the protocol and the path and everything. Okay, so let's stop this and go look at the index view where that link is defined. Okay, so here's the require SSL, and there you have it. Okay, so if I come over here and add a comma, oops, comma would be helpful. Now we can look at the overloads. Get the mouse out of the way, and I'll go down to the one that allows me to set the protocol, and there it is. Okay, so this is the only one of the 10 overloads of action length of the overloaded methods that takes the controller name, but more importantly the string. But I also have to specify the host name, as well as a fragment, as well as any other attributes. So this just really isn't very practical. And there's also nowhere for the port number. But you could add that to the host name is where you would actually put that. All right, so after an extensive Googling session one afternoon, I found that there are a ton of solutions that people have come up with, many involving some pretty nasty hacks into various components of the application, the .NET configuration files on the machine, and other, I can really only say kindly, creative solutions. The most elegant that I found was on Stack Overflow. Okay, so over here in Solution Explorer, I'm showing all files. And if I scroll down here, you can see that I have this require HTTPS attribute.cs file. So I'm going to go ahead and include that within the project. And I'll open it up. Okay, so here it is. And there's the link if you're interested in following up on it and looking at some of the information. Okay. Now, I only want this to be in effect when I'm running the application in debug mode in Visual Studio. So that's a nice thing because I can use these conditionals. So this code is only going to be included if I'm building the debug package. And you can see right there that I am. Okay, if I switch it to release, this code isn't going to be included. So what this does is it creates an override of the require HTTPS attribute. It's a very elegant solution. And specifically, it's overriding the handle non-HTTPS request. Okay, so that's something that is implemented by the require HTTPS attribute. So the important part here is that it uses the URI builder to create a new URI object based on the URL that was passed into the attribute. So that's the requested URL. And then it sets the port to the magic 44,300. Okay, so this is a magic number that's embedded within the code. And it assumes that you're only running one project in IIS Express. Remember that if I have a second instance, the port number for that instance of Visual Studio is going to be 44,301, so I'd have to change that. So there's various ways of getting around that, but this makes it very simple. All right, and then what it does is it redirects to that new URL. The nice thing here is that I don't have to set the protocol because the location header already had that set. It was already set by the default behavior of require HTTPS. Okay, so I've added this to the project. So I'm going to go ahead and run it again. And we get an error. So something with the action link. I included that comma. All right, let me shut this down, go fix that. Okay, let's try again. I'll turn on capturing that and require SSL. Okay, so now we get a different response. So we're making progress. So first of all, let's take a look at the request headers. Everything's pretty much the same there. Response. Cool. Location now has HTTPS and it has the port number that we need in order to redirect to that page. Okay, so what's going on here? Well, there's a problem with this website's security certificate. security certificate presented by this website was not issued by a trusted certificate authority. I know that. Thank you. So Internet Explorer is being a little on the paranoid side. Fortunately, they have this option right here. So I can continue to this website. Now, before I click this, I just want to let you know that there apparently are different configurations of Internet Explorer where when I first ran the application, sometimes on some machines, I get this page immediately, rather than that other page that just says there was a problem, and the only option was to try to fix the connection, which does absolutely nothing. Okay? So the behavior of Internet Explorer varies a little bit. Don't sweat it. You still have to do all these steps, so it's somewhat moot. Okay, so I can continue on to the website. Internet Explorer really wants me to know that this is a problem, that there's a certificate error, so it puts up a red address bar and so forth. But at last, within my development environment, I get the secret that MVC rocks, and I can look at the page and do some real debugging if there's any problems with the code and all the usual stuff. Okay, so let me go back now to home, and I'm going to copy the link and try this in Firefox first. I'll paste and go. Okay, so this connection is untrusted. So this is fairly similar to the behavior in Internet Explorer. I have some options for get me out of here. I forget what that goes. Yeah, it goes to just the default page. But I can also look at the technical details. So it's using an invalid security certificate. It's not trusted because it's self-signed. Okay. I understand the risks. Not only do I need to click that, I now need to read more and add an exception for this URL, confirm the security exception, and now I can go to that page and view it. Okay. So that's all working. That's a little bit different in Firefox, but at least I can debug. And let's take a look in Chrome. And I'll right-click on that, paste and go. Similar sort of thing. Big red screen. Boy, the browsers really want to let you know that there's a problem. Chrome even crosses it out. Okay? So, overall this is a good thing because if this was a real site I was visiting, I would not want to miss that it's a bad certificate. Okay, so I can go back to safety, which is blank page, or that doesn't even give me a back and forward browser. So I'll paste and go again, and I'll proceed anyway, require SSL, and it's a little bit less obtrusive, but it reminds me that there's a problem with certificate. But at least I can get to the secret, and I can work with the application and debug it. It's a little bit annoying that some of the browsers treat you like a child rather than a responsible adult, but I guess overall it's just wanting to make sure that I know I'm doing something incredibly stupid. But again, these hassles are just in the development environment. Normally, changing the protocol is all you need to do, and that just works within the full version of IIS. So overall, require HTTPS is a good thing, although certainly not without its quirks.